When you work on projections in PCG, it's nice to be able to filter by tag. You can choose to project something onto it or ignore it completely. But what if you want to project on everything, but just figure out what material is on it and then filter by the material? Well, that's what I'm showing you guys how to do today. I have 4 different materials here, each one assigned to a random just square. And you can see as I move this around, it is projecting onto it decals. This one has nothing on it. This one has mud stains. This one has cracks. And if I wanted to, I can select the entire PCG graph and tell it to spawn meshes instead of decals. And now, instead of spawning in decals, I now have meshes that are specified per material, and that's all controlled here. We can specify the material you're projecting onto, the mesh that spawns, or the decal that spawns, which means you don't need to have potentially multiple setups to do something like this. And it's relatively easy. Let me show you how it's done. As always, to get started, we're going to go to Edit, Plugins, search PCG, and turn on the Procedural Content Generation Framework, and restart your engine as needed. Now, here in the world, I have just 4 regular cubes for demonstration with 4 different materials assigned to them. Aside from the materials, they're exactly default cubes, no tags, no nothing, just materials. But we'll need 2 things to create the setup. First thing is, of course, the PCG graph, which you can grab from PCG Graph. We'll go ahead and create an empty graph. There's going to be a PCG_material filter. You'll also need a blueprint actor with a spline. So we'll go right click, go to blueprint class, grab ourselves an actor, and call it BP_material filter. Let's go ahead and open up the blueprint. Inside the blueprint, I'm going to go ahead and add a spline, and then I'll just drag this out a bit so that way we have a nice large area. And then in the detail panel, I'll search for closed to get closed loop and turn that on. After that, let's go ahead and add a PCG component, and then in the detail panel, we're going to plug in the graph that we created earlier, and that's all you need here. At this point, I can already drag out the actual curve into the world, and I'll just go ahead and put it up into the air a bit, and also just make it a bit bigger so that way it encompasses the entire area here for demonstration. Okay, so there we go. So that's all we have. Let's go ahead and open up the PCG graph. So the first thing, of course, we need to make use of the spline. So I'm going to right click and search for get spline data to get the information of the spline. And then I will use a spline sampler, and I'm going to change the spline sampler to be on interior. I'll change the interior sample spacing to something like 250, just so we don't have that many points. And I'll also make sure to turn on unbounded. Because this blueprint doesn't have a volume, it would automatically remove most of the points. So unbounded, make sure you actually keep all the points because, well, there is no volume. At this point, if I already selected in the bottom left corner for the debug, and then with it selected, press D, you'll be able to see the point grid. Occasionally, it doesn't immediately pop up, at which point just press A to get the information of the points, and then deselect A, at which point the point grid here will show up. So great, we have our points. Wonderful, that is working really well. Now we're going to be projecting the points down, but because it's currently a perfect grid, I want to randomly offset the points, so that way when it's projected down, it's not a perfect grid. We cannot do this after the projection, because if you project down and then offset it, it will be no longer on the thing you projected to. It potentially will intersect something else, be hovering in a place you don't want. So I'm going to use a transform points already, and in the transform points, I'm going to set it to be -100 in X and Y to 100 in X and Y. Just slight movement. Now comes the projection. We're going to use actually a relatively new node called World Raycast. I believe it was introduced in the past couple of versions. So we'll go ahead and use World Raycast here. So we'll need to customize this. We're going to use a line trace. That is fine. The main thing here is unbounded. We also want to turn unbounded on here because, again, we have no volume, so we want to actually just go wherever it is. At this point already, you could see it is projecting down on all these points, but you can see it is not hitting this object. This object is the default floor plane of this level, and in the detail panel here, you see it is movable. So it is set to dynamic collision instead of static collision. If I go ahead and change it to static and then click force region on the graph, you'll see now we get the points everywhere. So fantastic. It is actually working. We have all the points scattering in all of this. And if you want to control what you actually project onto, under filtering here, you can filter by actor tag or anything else, but we're not going to be using most of this. We're going to be fine with landscapes if it ever hits that, because we're going to be checking it by material. Now, how do we get the material information of what it hit? Well, that is under attributes. Over here, we can get reference to render material. Now, it does require B trace complex for use with primitive components. So we need to turn this on, and then down below under advanced, you can open it up and you can see it is tracing the world static channel, but it's not tracing complex. So we need to turn that on. Turn on trace complex, and now it'll trace the complex information, which in this scenario is good because we want things to be exactly on the mesh of whatever it is projecting onto and not on the collision, which might be a little bit off. So if I press A on here and I get all the information, I can scroll all the way to the right, and here you'll see impact render material. If I just click and drag to the right here, we can scroll a little further. You can see there's the proc grid material. If I scroll a little more so we can open it even more, and then scroll down, you can see there's our materials. There's the wooden floor material. There's a dusty concrete. So each point now has an impact render material assigned to them based on the material it is actually hit. If you're working with multiple material slots, you do have set render material index and get render material index, where you can turn these on and find out which index it is or specify the render material index specifically. This only works for static meshes, but in general, we're working with only one. So we just need the one get reference to render material checked on. We now have points projected down. Simple. Now we want to filter by material. I want to be able to specify what material do we actually want to project on and every other material I want to ignore. So I want to filter out basically by material. Now to do this, you will need a loop. I tried to do this without a loop, but unfortunately I ran into some issues. And I'll show you what happens with it after I have it set up. But to get the loop going, just right click, go to PCG, grab a PCG graph, again, empty graph. I'll call it PCG loop filter materials. And then I'll drag it into the graph, let go, and choose the loop node bottom option. At which point I can just double click to open it up. For the input here, I have the first input as label materials of a type loop. That's an attribute set and set to required. And the second one is a points, normal point with type, again, required. And the output is just a normal point set to normal. And all we need to do here is a single node called filter attribute elements. The in is from the points, the filter is from the materials, and the inside filter goes out. That's all it is. Simple as that. Only thing is we need to specify what are we filtering, and for that we need to change this to be equal. And the target attribute is this attribute right here, the impact render material. Now I don't want to accidentally mistype this, so I'm going to right click on it and copy attribute name. And then I can come in here and just paste it in and write into target attribute, so I know it's exactly correct. And the last can stay as is. Now in our setup here, we can plug in our points into our points, and now we need to plug in the material. Well, we haven't made those, so let's do just that. Here in the bottom left in the graph parameters, we'll go ahead and add ourselves a new parameter. I'll double click on it to rename. I'll call this materials to project. Now I'll click on this little capsule, and then in the search here, I will search for material interface. You want to get material interface specifically. If you get material or material instance, then it will be exclusive to just materials or just material instances. Material interface allows both of them, so it'll allow you to check for instances and not. By default, I'm going to set up the material here as the MI proc grid, which is the default grid that we have on the floor. And the other thing is I want to make this an array. So I'm going to click on the drop down and then change the type here into array. Of course, then we need to re-add it. Order of operations, clearly do the change it to array first. And now we have this, we can just go ahead and drag it into the world or just right click and search for get materials to project. So we can plug this in directly because we need to make this partitioned. So I'm going to search for attribute partition, and we can keep it actually on last because it's the only attribute, and plug that into materials. At this point, if I go ahead and debug this actual loop here, you will see that, hey, we have points everywhere except on these actual 4 squares. If I select one and press H to hide it, it doesn't even keep them underneath. It doesn't project through them. It just ignores it by filtering out the points that were on it and removing them. So if I just take all of them and hide them, you can see it is perfectly removing them. If you were to project onto a tagged object, for example, it would ignore everything except the tagged object, which is slightly different than we're doing here. But now let me show you what I meant by you needing a loop. I'm going to first go ahead and disable this transform points, just pressing E to disable it for demonstration. So now you can see a perfect grid. If I go ahead and detach this and then just use a regular filter attribute elements, we can configure it the same way. Target attribute will be the same as before. Plug this out into in, and the filter will be the materials to project. And then change the operator to equals, and then throw the debug in here from the inside filter. You'll see that it looks pretty good. So what's the problem? The problem comes when you add something to this array aside from one thing. If I add one more and we take a look, well, that's not right, is it? Instead of actually filtering out each one by both of the things in the array, each point has been given a random one of these, and then it checks against that. So that's why you need to loop on each one for each material. And it gets worse, of course, the more materials you have. So I'll go ahead and detach this again, as this was for demonstration, and plug it all the way through, and we're back to where we were. So awesome. From here, we already have access to things. So now I can already select the graph, select the PCG component, go down to the parameter overrides, and override the materials project here. There's our grid. And if I want to, I'll go ahead and just replace it. And you can see now we're just on this material. I can add another one, and for example, add another one. And just like that, it is now affecting both. Now, one thing to note with this method, if I was to take the static mesh here and move it, it will not automatically update this setup. You'll need to go in here, select it, go to PCG, clean up, generate, and then you have the right answer. Now, there is a way of getting around that while you're working on stuff. Inside of the PCG graph, I'm just going to right click and search for get actor data. It's regular actor data. In here, For actor filter, we're going to go all world actors by class, and we're going to search for static mesh actor and select that. We're going to select multiple, and very importantly, at the bottom, we're going to turn off track actors only within bounds. Again, no volume. So what this does is it actually pays attention to every single static mesh, and which means it will actually regenerate. Now, you don't want to have this on all the time. There's no reason for it. But while you're working on it, this is a good way of just immediately checking where it's going to be projected potentially for each object. And we don't need it anymore. You just press E and disable it. And then once again, you'll be back to where it was. So you don't need to delete it. Just go ahead and use it when you need. I'll keep it on for this demonstration though. At this point, we have a way of filtering materials. Now, what can we do with this? Well, we can do two things. One is we can spawn specific objects on the setup depending on the material. Let's say you wanted to spawn trees outside, chairs on the inside. One graph, you don't even need to separate things out if you don't want to. Now, that's a little harder because you probably want the spacing and everything on trees differently than you would want on the chairs. But one thing you could really use it for is decals. You might want to spawn different decals on different materials. Now, I'm going to be showing you how to set up both with a simple checkbox. So that way, if you want to specify to spawn static meshes, you can. If you want to specify to spawn decals, you can. But first, we need an array for the static meshes that we're going to be spawning and an array for the decals we're going to be spawning. So let's go ahead and add a parameter. I'll go ahead and rename this to mesh, and I'll click the capsule and search for static mesh, and we'll grab ourselves static mesh object reference. In the drop down, I'll change it to an array, and then hit the plus button to add a object here, and it'll add a default cube. Then we'll add one more parameter. I'll rename this to decal material, and just like this before, this is going to be a material interface object reference, and again, array where we'll add the decal that we want to project. I'll go ahead and plug in a decal here that I have. So great, we now have everything we need. So in here, I'll go ahead and actually re-enable this transfer points, and we'll continue from the loop filter. What we want to do is add this information to these points, but add it accordingly to the material. It has the material assigned to it, and we know what the material is because we're already filtering by it. So we want to match the other meshes and the decal materials to the same information. Index 0 of all of these indexes. So that way, index 0 of all of these arrays will be the same material that we're projecting on, to the same mesh we're spawning, to the same decal we're spawning. 0 is combined, 1 is combined, 2 is combined, etc. To do that, all we need to do is grab each one of these actual arrays, bring them out, and then we just need to use an add attribute here, the parameter version. And so I don't have to deal with the names, I'll select it and turn on copy all attributes here. And then I'll duplicate it one more time and plug it all the way through to also add the decal material. So on this last one, if I press A, you'll see right here, there's a decal material, there's our mesh, and there's the materials project. Now, the reason we have two despite seeing one here is because we're debugging this one, which is, of course, has it overwritten. If I go ahead and reset it back to default, you'll see we have one here just like the default. So from here, we can just use a node called match and set attributes. And the match data is the ones for the add attribute. Now, on the match and set attributes, we do want to customize how it matches them. Otherwise, it's going to assign them randomly. So we're going to turn on match attributes. The input attribute is the one we're matching to. So that's this impact render material. Again, right click, copy attribute name, and paste it into the input attribute. And the match attribute is the one we're getting from here. Now, if I go ahead and select the last one, we're going to compare it to the materials to project. So I'm going to right click on that, copy attribute name, and paste that into match attribute. So this will link everything together. Now, one thing I don't have is a way of controlling what I'm spawning, whether it's the decal or the mesh. Let's add one more parameter here. I'm going to change it to a regular Boolean. I'm going to select it and rename it to spawn mesh. And for convenience, I'll bring it up all the way to the top here. So now for match and set attributes, I can grab this spawn mesh and use a simple branch node. I'll open it up, and the output to be is our actual condition. So spawn mesh goes into output to be, out here to goes to in, and in output to be, we can use a static mesh spawner. So we'll drag out and use a static mesh spawner. It is grayed out because it is not enabled for the spawn mesh, so don't worry about this. This is completely fine. But in the static mesh spawner, all we need to do is change the mesh selector type to by attribute, the top option, and change the attribute name to mesh. Mesh because that is the name of the attribute that we're adding. If you named it something else, put that name in. So now we're not seeing anything because, well, we haven't specified that it's going to be a mesh. So we're going to select PCG here and turn on and override spawn mesh. As soon as I do that, you will see we get cubes everywhere except these 4 panels. And just like before, if I want to change the materials to project, I can just turn it on, plug it in, and there you go. Now this one has these cubes. Now what happens when I have multiple? Well, if I add a new array here and plug in another one, let's say this material, you'll see the cubes get spawned on those as well. Now why is that? Well, that's because we only have one input here. If you do not have an input for something, it will use the default. So if I was to add a new array here, you will see it disappears because the second one is now using nothing. It is using nothing, so it spawns nothing. But now we can go ahead and spawn spawn something else. Let's say cones. And you can see we now have cones spawning on here. Same thing with the wooden floor. I can go ahead and add a new material for the wooden floor. Just like that. It'll again put the default in until we add a new mesh here. And we can say spheres, and there's our spheres. And we go ahead and move this. It doesn't matter. It is projecting down onto this as normal. Just like that. So nice and simple. So awesome. We have this all working for meshes. Let's go ahead and make it work with decals. Decals are going to go out of output A. From here, we're just going to use a spawn actor. And for the template actor class, I'm going to search for decal to get decal actor. Now we're going to need to override the actual material of this decal actor, of course. So I'll turn on allow template actor editing, which will give us the template actor here. This allows you to customize things and plug in things manually. And under here, decal, 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 you finally get to the decal material. And that's what we want to be overriding. The reason I did this is so I can right click onto it and copy internal name. Once I've done that, I don't need the template actor anymore. I can turn it off. You can keep it on and customize things to your heart's content if you want custom decal settings. And then whatever you overwrite with this next method will still override whatever you have there. But what we need to do is go into the spawned actor property overrides and add an entry. The property target is what you just copied, and the input source is, well, our attribute. In our case, I called it also decal material, so we'll type that in. Now, if I go to a graph and change it to spawn mesh off, you will see decals are spawning, but that definitely is not our material. And we get an error here. Object override for object property decal material is invalid or unsupported. Well, that's interesting. Why is that? We copy that. Well, if I select any one of these decal actors, you will see that underneath it, it has a component called decal. And in here, if you select it, that's where the decal material lies. So in our spawn actor here, instead of input source decal material and property target being decal material, the property target, which is the decal itself, needs to be decal, the name of the component dot decal material. And as soon as you do that, the error goes away and you'll see there's our decal spawning. Now it's using the same decal on all of them, but that's because just like the before, we have not specified a new entry in here. If I go ahead and add 2 more entries, unlike the static mesh which spawns nothing, this will still spawn the actor, just not assign the material. So if you don't want something spawning decals on it, just don't have it in the things that can be filtered to, or rather materials to project to. And once we plug in the different things, we now can see we're getting different results on every material. Now it doesn't look very good. That's because they're all the same shape, they're all the same size, etc. Let's go ahead and give it a little bit of variety. Right before this branch node, we'll add a transform points node. Inside the transform points node, we'll scale it anywhere from 0.5 to 2, and we'll rotate it around 360 degrees. You do not want to move it here. We moved it at the beginning already. Otherwise, the whole world raycast and the projection will break in terms of where it is in the world. So this one just rotates and scales. And now we have a much better result. Now there's probably too many, but you can see here, it does do a good job if I go into game mode of now making that a lot more interesting. Now, again, too many decals here for its size especially. So I'll go back all the way to the beginning, the spline sampler, change the sampling to maybe be 400, and there you go. Now this does not stop the decal from actually projecting onto something else, but it does stop the decal from spawning on something else. So keep that in mind. If I didn't want to have this go all the way to the bottom here, I can add a separate transform points just on the spawn actor and then uncheck uniform scale and unlock these so we can scale the scale min to something like 0.1 in X. And you'll see that it no longer goes all the way down. It only goes down a little bit here. So it's no longer projecting all the way down to the bottom. Of course, does not stop things like this from happening, but assuming your materials are far enough away, just like so, you can see it goes ahead and adjusts. So that's how we're able to really quickly add some variety onto this rocky road, add some cracks and things on top of this nice smooth concrete, break it up, make it nice and interesting, add splatters and wood, all with the same setup. So that way you do not need to have 5 different PCG graphs to do all this. Have one and filter by material. Now, if you want to spawn a random decal, for example, or random mesh on top of this full setup, there's a few ways of doing it. One of them is to have that setup and use a copy points to replace the current points with that version, but you have to filter then per decal and per mesh, which is going to be a whole thing. Or you can make a custom actor that has the randomization built into it and override the value for that instead. So instead of spawning a decal, you spawn a blueprint with the decal setup, and then based on whatever you specify in the input, you'll go ahead and do whatever you want from there. But just like that, we can go ahead and scale it randomly, rotate, doesn't matter what we do. It all has a nice randomness to it and works together. And this one, if we go ahead and move this up, you can see it can go ahead and block projections onto it because it hits this and ignores that. As the last last thing, if you didn't want it to actually project onto this thing at all and you want to ignore it, in the detail panel, search for tag, add an actor tag, let's call it ignore, and the world raycast, open up your filtering on the actor tag filter. Instead of none, change it to exclude and add the tags ignore. And now it will no longer actually project onto this object just because of the tag. So nice and simple. And of course, we can go ahead and remove the tag and it'll go ahead and project onto it. So for certain setups, this is going to be quite nice. Like for example, having a nice outdoor area and an indoor area where you're going to want to maybe put some mud and some water splashes as decals around. And when the person kind of gets in, you want to tell the story of, hey, they're splattering the mud everywhere. So you want to put mud on the hardwood floors. This will allow you to do both in one easy maneuver. As always, I am going to have this project available on my Patreon, where you can join these wonderful people here supporting what I do. It really means a lot. If you'd like to join the community, the link to the Discord and everything else will be down in the description below. If you want to learn more about overriding properties on actors with PCG, check out this video right over here where I go over just that.